Hello guys, welcome to my channel. So today we are going to solve this particular problem, subarray with a given sum. So this is basically Geeks for Geeks platform. It's a really good platform if you want to practice coding and solve problems for interviews or in general for practicing. Okay, so this is a very popular problem related to arrays. And this has been asked in a number of companies: Amazon, Facebook, Google, Visa. Okay, so let's understand what is given in this particular question and what are they primarily asking. So you have been given an unsorted array of size n, which basically comprises of non-negative integers. So it's very important because if negative integers are included, this particular question becomes a bit complicated. But now since they're non-negative integers, it's comparatively easy. And the array is also unsorted. Okay. And you need to find a subarray such that the sum of that particular subarray is nothing but equal to the given number s. Okay, so like when we talk about say n equal to 512, so output is 2, 4. So you basically have to give the output as nothing but an array comprising of the left and the rightmost position. So here they have basically used one indexing. So 1, 2, 3, 4, 5. So 2 to 4. So 2 to 4 is this. 4 is this, 2, 3, 7. So 2 plus 3 plus 7. So it's 12, which is equal to what is given as S. Okay. So now what would be the naive approach? The naive approach would be to find all the subarrays, right? So the time complexity of that is O of n square. Now here you can see the constants that n is equal to 10 to the power 5. So O of n square is definitely not favorable. Also in this particular question, it is given that the expected time complexity is O of n, and also you don't have to use any extra space other than this particular vector that you are returning. So what are we going to use here is something what is known as a two-pointer technique. Now this is something which is a very important concept that you need to learn, and it's widely used in a number of problems. So let me just briefly explain you how are we going to do this. Okay, so as the name suggests, it's a two-pointer technique. So this is the particular question, subarray with given sum. So we are maintaining 2 pointers here, left and right. Okay, so left is the leftmost position and you have the right. Now what are you doing here is, initially they both are at the same position, the index position. Now what am I doing is, I am moving my right pointer on the right hand side. Okay, so suppose if I move it to the second position and I'm increasing the current sum. So initially the current sum was 1. Now when I increase, the current sum is 1 plus 2, 3. Now I again move it, just a minute, sorry, yeah. Now I again move it here. So it's basically 5 plus 6. Okay, now here you see the sum is still less than what is given. We need to find the current sum needs to be 12, right? So, but the sum is still less. Okay, 1 plus 2 plus 3, now it's 6. Now as you move here, the sum becomes 13. Okay, 1 plus 2 plus 3 plus 7, so it's 13. Now this is more than. Now since it is more, what am I doing is, till my sum again becomes less, I am moving my left pointer. So my left pointer was here, now I'm moving my left pointer by 1. And what am I doing? I'm subtracting this value. So initially it was 13 and I'm subtracting 1 out of it. So now the value is 12, which is the sum that is required. And if the current sum becomes equal to the sum, I am simply breaking from the loop and I'm returning my left and right values. Okay, so let's look at the code once. We basically have to write this particular function. So as I said, we have two pointers, left and right. Initially both are pointing on the 0th position, the first position, and I am maintaining a variable current sum which is 0. Now what am I doing is, I am moving my right pointer towards the right, okay, till it's less than n, and I am incrementing my current sum. Okay, I'm incrementing my current sum till a point my current sum is less. As soon as my current sum becomes greater than my target sum, that is my S, what am I doing? I am subtracting my left value. I'm subtracting my left value. When I come here, my current sum has become more. So what am I doing? I am subtracting my left value and I'm incrementing left by 1. That's exactly what is here, L plus plus, right? I'm subtracting my left value and I'm incrementing it by 1. Okay. In case if you don't understand what is happening here, basically this is what am I doing, and I'm incrementing L equal to L plus 1. Okay, and in case if my current sum becomes equal to given sum, then I'm simply breaking, because then I've found my subarray, and I am incrementing my R plus plus. I'm moving towards the right till it's less. I'm keeping on incrementing it towards the right. Okay, so once this loop is done, you have to return a vector of left and right position. Okay, so since it is, okay, so here you need to check. Okay, so here if you don't find the answer, both of them will be greater than n. So that's why I'm checking that they both are less than n. Okay, if they both are less than n, because the left and the right index position should be less than n, I am doing is I am simply pushing them back into the array, right? So left. The reason why I've given +1 is basically because the answer is expected in index position, in one index position. Okay, and we are starting from 0. Okay, so and in case if this constraint is not followed, I simply have to return a vector comprising of -1, and I have to return it. Okay, so let's try to submit it and see if it's working or not. So yeah, it was the correct answer. So yeah, so this was the explanation of this problem. Hope you guys understood it. Feel free to drop down your queries and suggestions in the comment section below. You can also find the link of this particular question in the description. And yeah, if you found this particular video helpful, don't forget to like, share, and subscribe. And see you in the next one. Bye.